Okay? So 14, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Okay? Just like this. And we're going to label some things. Okay? Stomach acid is a 13. I forgot to label this part. I'm sorry. On the left side is acid. On the right side is base. Okay? You guys see this okay? Okay, so stomach acid is 13. Lemon juice is a 12. Soda pop, like Coca-Cola or Pepsi or RC, Dr. Pepper, cola brown pop is the same as vinegar, and it's about 11 and a half to a 12. Have you ever heard of Mountain Dew mouth? If you've ever been to the dentist and you've got tons of cavities all through. In college, I lived on, for 2 years, I could buy a bun, like a hamburger bun, for a quarter at the lunch counter. We didn't have a kitchen in our dorm room. So I could buy a hamburger bun for a quarter, and then I could take it over to the condiment bar, and I would get ketchup and mustard and mayonnaise and lettuce and pickle and tomato and onion, and I would eat a vegetable sandwich, right? That was my lunch, and often I would have 2 of those for dinner, and that wasn't enough. That's clearly not enough nutrition, but to keep me going, I would buy, for $1.25, I would buy the biggest cup that they would give me for pop, and I would drink Mountain Dew. And you got free refills, so I'd keep my cup for like 2 days. And I would drink Mountain Dew all day long and eat those sandwiches. And so carbs, lots of sugar and lots of pop. And I had 9 cavities when I got married. When Doug and I got married and I got insurance, I had to go to the dentist and I had to have 9 cavities. I actually had Mountain Dew mouth. I completely destroyed my health. I was so sick from eating like that. But I would drink Mountain Dew. I would probably drink 2 or 3 of those a day. I was so sick. And look, it's because, look where that is on the acid chart. I'm lucky I didn't, what did I do? Somebody should have sent me some nutrition counseling.
It doesn't even taste good.
No, it didn't taste good, but I was super poor. Okay, so lemon juice and cola are between, lemon juice is a 12, cola is right in there, 11 and a half, and it's right there at the same amount as vinegar. Okay? Next down is wine, which is a 10 and a half.
Yummies.
No, Lou. Really? Wine, and then tomatoes are a 10. Wow. Oh boy. Coffee. Coffee is a 9. I'm having a very acidic.
Side, right?
Yes, we're still on the acid side. And then this is hard to believe, but rain is actually an 8.
Acid rain.
Yeah, rain. And then your saliva should be somewhere between a 7 and an 8. And then milk is not quite a 7. It's like a 7 and a half.
Oh, dang.
It's a little acidic. Okay? You don't have to have all of these. Just do your best to write what you can. Because this is, A, it's super interesting. And B, it's going to help us later on in our experiment. Now we're going to come over to the base side. And just below 7, which 7, go ahead and draw a line through 7 because it's not in our book that way. But I want you to delineate, make a defining line of where the acids stop and the bases begin. And water goes on both sides. It's not in our book that way, but I want you to do that so that you know that acid is, what's that word? Amphiporic. Amphiporic. Okay? So we have that written down here that water is right in the middle at a 7. Now, just below water is human blood. Human blood is just a little below 7. Seawater, sorry.
Does that mean if you put like a weak acid in it?
No, well, it could react as an acid for a weak base or for a strong base. But if you put an acid with it, the human blood would act as a base. That's correct. Okay, so number 6, that's why ulcers, bleeding ulcers in your stomach are so bad. Because your stomach pumps out hydrochloric acid, and then you're bleeding into your stomach, and we're having a chemical reaction like there's food in there. It's a bad deal. Super bad, and it just makes things worse. Just keeps going. So, okay. So human blood is just below a 7. Seawater is just below an 8. Wait, did I do that wrong? Oh, gosh. Oh, no, I'm right. Sorry, guys. pH. Oh, I did do it wrong. Oh, no. I wondered why it didn't make sense that our vinegar was not a 1. It's okay. We'll go back and fix it. Just keep going down the list, and then we'll put the numbers in the correct order. Oh, man. I taught you wrong. Okay. Seawater. Then borax is under seawater, and it's about where the 5 is. Borax is a laundry detergent. Then lime water, they make that with limestone, and they put that on gardens and things to help neutralize high amounts of ammonia.
Seawater, I think?
I didn't hear you.
What was the number for seawater?
Seawater is right around a 6. It's not quite a 6. It's like between 5 and 6, but it's in there.
Thanks, ma'am.
And then lime water is between 3 and 4. Yeah, Papa.
So why do we bring these?
I'm going to do an experiment in just a little bit. And then household ammonia is around where the 2 is. And then household bleach is between the 1 and the 2. Okay, so your chart should look like this.
What would happen if we put bleach and hydrochloric acid in?
It would be extremely explosive of a reaction.
Like, don't these just make gases?
What?
Don't the base and acid reactions make gases though?
Nope, that's a question in your notes. What do acids and bases make for a piece of candy?
Oh.
Check your notes. Hurry up. Check them.
They're downstairs.
Your notes that we took today.
Oh.
Hurry. And while you wait, I'm going to redo my numbers. Because the numbers should start at 0.
I want a piece of candy.
1, 2, 5.
Salt water concentrate. It's like a salt water concentrate.
Nope. Salt and water. That's correct.
Yeah.
So Zach gets candy. Because he will do anything for candy.
Candy? I want candy. I want candy.
Okay.
Mama, can I have candy?
Livy, quit. Okay. So your chart should look like this now. Just reverse the numbers. 0 at the top, 14 at the bottom. Okay. Sorry about that, guys.
I was kind of wondering about that.
Yep, you should always say something because the big ideas, I have them down great. The details, I always stink. I messed up the details. Sorry. Okay. Now that we have this, we'll move on really quickly and go through strong acids and strong bases. Zach brought me right to that. Zachary? Nope. Not yet. All right, strong acids and strong bases. This one's going to be on your test. You're going to want to circle it, star it, do all the things next to it. Okay? Just a minute. Okay? The 7 most common acids, strong acids, are. Okay, everybody has this so I can erase, yeah? Okay. They are, write these down and then I'll tell you what they mean. HCl, which is hydrochloric acid. Okay? Next is HBr, like this, lowercase b.
You know what hydrogen?
Hydrobromic acid. HI, both capital. HNO3. HClO3 and HClO4. Okay, you can copy mine, okay? Now we knew that we could count on there being a hydrogen, right? Because acids, they have to have a hydrogen. That's kind of part of them. I wish that they would stick that in as part of the definition. Okay? But let's notice this. Chlorine, bromine, iodine. Yes.
I think we're missing one, so I only see
Yep.
6.
Yep, you're right, Annie. We got another one coming. You're right.
Sorry
Okay?
about that.
Not at all. That's good. Nitrogen, chlorine, chlorine. The INE. What are all of those guys? Oh!
Halogens.
They're halogens. They're halogens. Remember, they make those special bonds with those that have one extra electron. What has one extra electron?
Oh, the
Hydrogen. Match made in heaven. Dun, 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 right? Except that when they have too much hydrogen, they become an acid. Okay? And the oxygen helps too. All right. Now, Annie was right. And then nitrogen doesn't quite fit in it, but it's really, really close. Right? Nitrogen's really, really close to being a halogen. It's like right next door. So we'll just include it. Now, the other one is a weird, fluky one, and it is H2SO4, I think. Yeah, H2SO4. And H2SO4 is a weird, fluky one because sulfur, if we look at the periodic table, where does it fit? It's over there hanging out with,
halogens.
it's close, but not quite. Okay? All right. So now, the most common soluble strong bases are the ionic hydroxides of the alkali metals. Are we surprised? Heck no! We have all these halogens, and we know they love the alkali folks, so of course they're going to react with the alkalis. That's going to be on your test. Mark it down. Okay? The most common soluble strong bases are the ionic hydroxides of alkali metals, and then also NaOH, KOH, and the ionic hydroxides, just hydroxides is, and the OH forms of alkali earth. Metals. Why are we surprised? We're not. Why would we be surprised? The alkali metals and the alkali earth metals love to get with the halogens because they each have what the other needs, a lac and an overage, right? Okay, mark it down.
OH forms of what?
OH forms of alkali earth metals. I'm going to break out with my elementary book, Nobody Cry, It's Going to Be Okay. Let me see if I can. I have to go this way, that won't do.
Watch out, it's almost 10:30.
I know, I have to hurry. There. There you go. Okay, and then you can continue to copy that. I am going to get out my Ellen McHenry book because I want to do the periodic kingdom with you guys. I've not done it yet, and you need to know it. It's like the coolest way to explain the periodic kingdom. Dear book, help me find it. Ah, right there. Okay, so the periodic kingdom is a cartoon that Ellen McHenry drew of the periodic table. And she's got a little silly story about real chemistry. So I'm going to back up and I'm going to read it to you like I read it to my little kids because it goes perfectly with these acids and bases. Once upon a time in a land all around us was the periodic kingdom. The royal family of the kingdom lived on the eastern shore of their tall castle tower. They were the noble gases. King Radon, Queen Xenon, Prince Krypton, Prince Argon, Princess Neon, and baby Helium. The noble gas family were the most peaceful rulers a kingdom could hope for. They never got upset and they never argued with anyone. They remained calm no matter how much turmoil was going on all around them. There was 1 square mile of land just outside the castle. Over here in the noble gases, this is what we're talking about. It's about to be the bad guys. Okay? The land had been divided diagonally, split between 2 large families. The Metal family had set up a homestead on the southwestern corner. The other family, who lived in the northeast, had such a long last name no one could ever remember it, so they became simply known as the non-metals. Over the years, some of the members of the Metal family married members of the non-metal family, and they lived right in the middle, along the diagonal dividing line. This new family was half metal and half non-metal, so they became known as the semi-metals. After several generations, one of the grandchildren decided he did not like being called a name that sounded like half-breed, so he decided to change the family surname to Metalloid. Doesn't that sound cool? Metalloid. I like that better than not half metal, right? Okay. In general, the members of the non-metal family were very conscientious and hardworking. Why, without carbon and oxygen, life on Earth couldn't exist, don't you know? However, one section of the non-metal family had gone bad. Oh yeah, they all lived on the street nearest the castle tower. They were so jealous. The people of the kingdom called this street Crime Alley.
Wow.
These poor wretches were always in need. Desperate to gain an electron, they'd stop at nothing. Whoops, I missed the page. They would even steal or kill to get their electron. They were people were ashamed to be associated with them, and the non-metals began calling them by a different name, the halogens. Halogens. Oh, get it? Isn't it funny? Okay. Some folks say that this is a sarcastic reference to a halo. I think it's based on a statement someone made about them not being worth their salt. Either way, stay out of their neighborhood if you know what's good for you. I'm going to skip the Middle Kingdom because it's mostly honest, hardworking laborers, cobalt, nickel, copper, zinc. And now we're going to scoot way over to the western edge of the kingdom to a band of outlaws. A band of outlaws named Alkali Brothers. These outlaws weren't the ordinary type. They were more like Robin Hood and his band of merry men. They represented generosity gone wrong. The members of the Alkali family have an extra electron that they'd like to get rid of. But instead of being nice and simply offering it to the poor, they force the poor to take it whether they want it or not. The alkalis would resort even to violence and, if necessary, kill to get a poor atom to accept an electron. Anyone who came near an alkali is in danger of being forced to take an electron. Except the royals, that is. They live an enchanted life, unaffected by the troubles all around them. Some of the alkali outlaws will eventually recognize the error of their ways, and they tried to reform, and they moved a little closer to the center of town. Some say they had come back down to earth, meaning that they had become more realistic about life, and they added earth to their name and called themselves the Alkali Earth family. Now that's enough about that. I just wanted you to get the idea that alkali and halogen are really important in the chemical world in terms of how they cause reactions in the world and how they relate to acids and bases. Acids and bases give you the basic idea of chemistry all in one unit. And I think that's great. I love it when things match up and they connect. And I hope you enjoyed that little connection there. Now we are on to our last question. I want you to make a generalization about acids and bases based on this new knowledge, okay? And that generalization that I want you to write down, you probably should star this, mark this. It's going to be on your test. A little mark right here so I know to put it on the test, okay? The most powerful acids and bases are made from the most reactive elements. In general. It's not perfectly true, but in general. Okay?
Can you say it one more time?
Of course. The most powerful acids and bases are made from the most reactive elements. Okay. Sissy girl, will you take this down and put it on my desk for me? Because it's time for us to now move on. I'm going to set up the experiment and I will wait for you. Yeah. Yes. Yes. Thanks for being my helper, Big. Okay, let's go ahead and clear off our desks. And for you guys, that means just get me a nice open space on the table there so that we can do our experiment. Zach, I'm going to ask you to be my helper with this because you live here. And ladies online, I am going to move you over to the table. We may have to shut the curtains so we don't get too much glare. We'll see. Okay? Okay. Noelle, would you set these up in the center of the table, take the lids off of them for me? Okay, Zach, will you clean up after Libby? And then I actually have some fresh coffee that I brewed for us today.
I'll get it now.
I think so.
I think that'll be strong enough. Okay. I have to say, I'm really enjoying having a little more space in my house than I generally do in our classroom. It's a little easier to stay organized. Okay. Into each of the jars on the table. Okay, really?
You know,
Maybe.
Do you think I'd be allowed to put my shoes on? Huh? Do you think I'd be allowed to put my shoes on or should I? Yeah. I didn't know what you did.
What did you say?
Oh, I was wondering if I could put my shoes on.
Yeah.
Thank you.
Okay, Zach, I might need you.
Okay.
We can't do the experiment without the cabbage juice.
Thank you. Right there.
Okay. Classic Mrs. Kerner, right? Okay. And then I'm gonna move everybody over here. River, oh river. Gotta take care of this. This can't be here. Okay. Well, we might have to run it under some hot water bag. Try to go this way. I think you'll be able to see there. Okay. River, my goodness. Okay. Did you get it? No. You're gonna break it. Good job. Okay. Okay. Ready? Now I put the tablecloth down here. It's gonna swivel coming out.
Oh, sorry.
There you go. Okay, so we need to have about half a cup in each of these, and it does smell a little farty in here. It's the cabbage. Okay.
That's what I want to smell.
Yes. Nobody needs to say excuse me. It's cabbage. Okay.
It's a really cool violet color.
It is pretty, isn't it?
Almost reminds me of the violet Jeremy made.
Yeah. Wait and see what we do with it. Okay.
Oh.
Let's see if we can. Yes. Yes. It's very stinky. It's very pretty and very stinky.
Pretty but stinky.
Zach, would you finish
Oh.
this up for me?
Yeah.
Okay. Look at that, Wolgar. Okay. I actually have a lab
Oh yeah.
sheet for you today. Yeah, you smell it now? Yeah, it's a little stinky. Sorry. Stinky, stinky. It's okay.
We might not have enough for
3 left. Well, we may have to rob a little Peter to pay a little Paul.
I'm not robbing food. You have to rob food. I will.
That's a good joke, Zach. Okay.
Dang it.
It's okay. We'll just pull a little off.
This one.
Yeah.
Stole it. Bob robbed Peter.
All right. Now we're ready. Okay. Let's see. Are we close? Can we do it?
If I did it.
Livy can't bump, okay? Can you guys see all the jars?
Yeah.
Okay. I'll bring you around. Okay, Livy, I need you to go on this side, okay? All right. So it will help me if you guys take one of these. Okay? You want me to turn the fan on? It's okay. The cabbage says, excuse me. It's a little stinky. Okay, so I did not print one of, I have one printed for you guys, so you'll just kind of follow along with us. What you need to know, ready? Liquids all around us have either acid or basic alkaline properties. Let's see if I do this. For example, acids taste sour and bases taste bitter and feel slippery. However, both strong acids and strong bases can be very dangerous and burn your skin. If you'll remember when we did the soap experiment, we did not want to get any lye on our skin because it's a very strong base and it'll burn. Okay? Yep. So we have the pH scale and it's listed on our lab sheet. The strength of the pH scale is determined by the concentration of hydrogen atoms. That's what pH means, right? A high concentration of hydrogen ions indicates a low pH, okay? And a high concentration of hydroxide equals a stronger base, and that will give us a higher pH, okay? And remember that water is neutral. In this lab, we're going to use the juice from a red cabbage as a pH indicator to test common household items. Okay, the red or the purple that's in this cabbage is actually an anthocyan, and we'll be able to see the color change if we do it successfully. Okay, so I've got lemon, soda pop, hand sanitizer, I have red vinegar, baking soda, shampoo, and conditioner. We have some other things that we're going to add to it, but I'm going to bring our bin over here. Let me get out of there. I do have some hand sanitizer here. This is my Thieves variety, but it'll be fine. So in your lab, Noelle and Zach, I'm going to have you run this lab. Okay? And we're going to start with number 1. In the first jar, we're going to put some water. So I'm going to get a cup, a Dixie cup of water, and I'm going to get it out of our Berkey so we know that it's perfectly filtered. And you're going to add water to the first one. And I'm going to get some tape, and we're going to label as we go. And you'll write down what you find. Okay?
When do you want me to add?
Did you get the tablespoons out, Zach? Get the tablespoon measure out of our bin.
Okay, you stand up
Now there's a code in our lab, and depending on what color the cabbage changes, if it changes to pink, the pH is 1 or 2. If it turns to dark red, the pH is 3 to 4. If it's violet, 5 to 7. If it's blue, and you'll see a change from blue. The color it currently is violet. Okay. If it turns blue, it's approximately an 8. If it turns blue-green, a 9 to 10. If it turns yellow to green, it's an 11 or 12 in terms of pH. Okay? So go ahead and add the water, Zach.
a little bit.
And 1 tablespoon. And then I want you to get a butter knife out and stir. Liv, I'm going to ask you to get down. Okay? Because I don't want you to get in there. What happened to our water? Go ahead and stir and observe. What happened when we added water to the cabbage?
Nothing.
Nothing. So let's label that in our chart as the control. Okay? Nothing. Next up, we're going to take that tablespoon measure, and Noelle, I'd like you to squirt about a tablespoon of hand sanitizer into our second jar, and I'll label that. And
See the water or the second jar.
okay, let's move it over here. Zach, go wash this in the sink for me. That one is hand sanitizer, and this one's water. Can you see them now?
Violet.
I think it's turning a little more pink. What do you think?
I think it's her
Oh, yeah,
violet.
definitely.
Can you guys see? No?
Maybe if you'd put it
That better?
against the light so they're kind of like this.
Yeah, let me move you. Thanks. That's a great idea. Thanks, Noelle.
Oh, no problem.
Yeah, for me. Is that better? Good. Great.
Yeah.
Let's
We all
turn-
just look black.
Yeah. Okay. All right. Let's label this one sanitizer. Okay. So for this one, we see that it turned a little bit of a color here. What color would you say? Kind of a pinkish violet, maybe? What do you think?
Yeah.
Let's label that one a 5. So in your lab sheet, label, ready? In your lab sheet, I'd like you to label hand sanitizer as a 5.
Huh? Which one's mine?
That one, take that one. Okay? Then we're going to do lemon soda. We're going to do a tablespoon of Sprite. Okay? And we have our tablespoon measure's been washed. So I will write down on our tape Sprite. Lemon, lime, Faygo, whatever. Any of that would have been fine. So Sprite.
Oh, yeah. Should I go get a towel? Would you mind?
It's okay, Zach. That's why I put the tablecloth down.
Still?
We might need 2 tablespoons into that because it had a little bit more.
Okay.
Okay. Okay, and use the butter knife to stir. Do you see a change?
No.
A little bit, maybe.
Slightly more pink.
I think it is slightly more pink.
So a
Ooh,
5.
look, I think the hand sanitizer is changing. I think it's bluer than it was at the beginning.
I think it was just like a Prussian blue.
Yeah, I think we need to change our lab sheet. Because if it turns blue, it's closer to an 8. Let's change it. Do you think it's more blue?
Let's just turn it into a 7.
Well, a 7 is this. This
Oh.
is our standard. This is our standard right here. So is it more blue or is it more pink?
More pink.
I would say a little more blue. So let's increase it to like an 8. Let's change it to an 8. I think the hand sanitizer is base. Okay. And then when we compare the Sprite to the other, it might be a little more pink, but I think it's still about the same. What do you think?
So an 8.
So we'll leave the Sprite a 5 to 7, which I find very interesting. All right, next up we're going to cross off apple juice and we're going to write lemon juice. Okay, and I will wash this for you. If you will get a fresh, tablespoon measure, Zach?
Yep.
And I'd like you to put a tablespoon of lemon juice into the next one.
Is this the same as a tablespoon? I don't think so.
Yeah, no, half of that.
Half of that.
Yep. So here's our sanitizer, water.
Is Sprite listed under lemon soda?
Yes. Sprite is lemon soda. And then so lemon juice, whoa, we have an immediate reaction. Scoot it closer to the camera, Zach, so they can see.
Ooh, right.
And what happened? Oh, I'm standing right in front.
Pink, pink, pink.
Definitely
pink, pink.
turned pink, didn't it?
Lemon.
Okay, so I have to write down lemon juice.
Is a
And lemon juice, since it turned kind of red, like a dark red.
Yeah.
Check on the front page what approximate pH do we have.
does anyone have one that's not in black and white?
No.
Like
It's
three
the
or
code
four?
is right here, honey.
A 3 or 4?
Yes, it should be labeled as a 3 or 4 because I would say this is dark red, especially when we compare it to our water.
Oh yeah, that's definitely dark red.
Okay. So lemon juice will get a pH of about 3 to 4.
White.
Okay. Next one down the list is white vinegar, and I don't have white vinegar. No, Zach. I have red wine vinegar. Did I stick it in the fridge or did it? There. Okay, good.
Excuse me.
Noelle, would
can I
you
have
like to pour this one in?
Sorry.
Sure. Just don't breathe it in.
Okay.
Hey, Mama. Can I have some?
We only have about 3 minutes, so let's make sure we.
Okay, but I want some of it too.
No, you don't need to drink it.
Why?
Go ahead and fill the tablespoon up. Good. Pour it in, and then let's cap it and let's move it in front of the camera so we can see. It's okay. Can you hand me the cap?
Yeah.
Okay, and let's scoot it up there next to our water and see what we get.
That's a really dark red.
It's another dark red, so it's similar to lemon juice. We'll label our vinegar. Okay, next up is baking soda.
Want to do this one? Sure.
So let's label the vinegar, please. And then I have,
Oh, my goodness.
for our baking soda, do you have baking soda over there? Okay, excellent.
Oh, you can just stick.
It's fine. It's okay. It's just fine. That's why I put the tablecloth down. Easy cleanup. We literally will just peel it off and throw it right in the wash.
Perfect.
There you go. No biggie. There you go. It's on the table. Yep. Pull it out in front of the camera so the girls can see.
Ooh, this one's gonna be blue green, I'm guessing.
Go ahead and stir, 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 and see what happens.
You were right.
Wow, we're getting a strong blue color.
So cool.
Hey, Mama, this one's turning purplish.
More purple.
Yeah, it's an 8.
Yeah, like it is purple.
Okay, we have a strong blue color, like a navy blue here. Can you girls see the color when
Almost
she
like a
stirs?
A blueberry
Okay.
brisk.
Yeah, like blueberry.
Blueberry brisk.
Okay, so we'll label that one as baking soda.
Next one is shampoo. This one's shampoo. This one's shampoo.
So would that be an 8 or a 9?
It'd be an 8.
I would vote 8. I would say. You put this on the baking soda. What do you think? If you think it's a 9, go for it. Or
Maybe hand sanitizer is a violet now.
Yeah, it keeps kind of changing. I think that they want us to use cheap hand sanitizer, but I left my cheap hand sanitizer at Co-op. So we're using the good stuff today. That's okay. All right, shampoo goes into the newest one.
Oh.
And I'm using cheap shampoo for this.
I'm just gonna start with it because it has.
Yeah, I think so, Zach.
That's a pink.
Wow, big change, huh? Can you imagine why
Top.
you have to buy special shampoos if you have if you've dyed your hair like hot pink or blue or like those orange colors? Libby, don't sniff it.
Why?
Wow, I would even say this one is getting close to red. Or let's see if this is dark red. You think that's dark red? Oh, dark red, pink. I don't know.
Dark
This
red.
one's looking
Dark
more
pink.
pink now.
Hot pink.
The lemon juice is looking a little more pink. So, okay, let's do, what's the next one? Conditioner. I think we're getting a little tight on time. Let's do conditioner next, and then let's get to the blue. Oh, he squirted it all over the table. That's good, babe. Okay.
We're gonna have to start with this.
Yeah.
There you go. This one's gonna be.
Chunky.
Yeah. Could be a dark purple.
Yeah, that's like a.
Wait, Jackson, if you get a chance, I'm putting things on the ledge here, shampoo and conditioner that need put down. Okay, what'd we get? Ooh, we got blue. I think it's turning more blue.
That's normal.
It's purple, but I think it's more blue than. So if it's between blue and purple, let's say 7 to 8. Yeah.
Yes.
And then let's get a fresh measure And do half of that. You know what? You're wearing all black. Let me do it. I'll do the bleach so that if anybody gets any spilled on them, it'll be me. Okay?
Because I'm wearing crappy stuff that's a little bit. Here, I'll do the bleach because that's a nice dress.
Thank you, babe. You're awfully sweet.
This
to me.
smells good.
And I won't look weird if I have bleach because
Okay. Just do half. That's good, bud. That's good, babe.
There
Now bring it to the front. Bring it to the front. Quick. Bring it to the front. Quick.
Whoa!
Bleach.
I
Whoa.
don't think that one needs stirring.
No, I don't think it probably needs any stirring. Since it turned a yellow green, what can
Right
we say?
away.
It's a very strong base,
Liquid.
right? Libby, the one that's purple and chunky, would you please?
This one?
Yep. No. Purple and chunky. That one's
Instant.
conditioner. Yeah, instant bleach. So I'll write bleach on that one. And then the last one that I want to do with you guys here with me is the Dr. Pepper. So Zach, would you label the bleach? And I had some others to try, but these are the big ones I want you to notice. Make sure you fill out your lab sheet to take home with you, and then you can read over that again. Zach, I'll just let you free pour because I think I'm out of tablespoon measures. Okay? Let's scoot it back. They can't quite see. And let's